Hello everyone, I'm Dr. Fawzul Atiq. I'm giving some series of lectures on the course Probability and Statistics. So in the previous lecture, we have discussed about the conditional probability, that is the probability of an event A given that another event B has already occurred. So probability of A given B. So now we know that some properties of probability. Now all these property which are satisfying for ordinary probability, it will also satisfy for the conditional probability, right? So these are the properties. Like probability of an event is always positive quantity and it should be within 0 to 1. Probability of the that sample space given that another event if already happened, it is 1, right? So these are the axioms of probability we know, right? The three axioms, they will also satisfy for the case of a conditional probability. So union of I equal to 1 to infinity ai given f that their individual probability summation of I equal to 1 to infinity p of ei given f. Again, the probability of the null event given another event f has already happened, it is 0. Probability of the event e complement given that f has happened, it is 1 minus p of e given f. So this is very important one. We will use it in several places. Again, if two sets are there, if A is subset of E, then probability of A given F is less or equal to probability of E given F. So these are the property we have already seen in case of a ordinary probability, and they will also satisfy in case of a conditional probability. We have few more, that the union formula, principle of inclusion exclusion. So probability of the event A union B given F is equal to probability of A given F plus probability of B given F minus P of A intersection B given F. And then if we extend this formula, we know that if you have n number of events, their union is that all of them are individual probability sum. Alternatively, plus or minus, take two combinations, then plus 3 combination, minus 4 combination, like that. We will have this event. We have discussed these things in our ordinary probability proposition. So they will all satisfy in case of a conditional probability. So we should keep note of all these properties. So I'm showing it again. Okay, now we'll discuss about the multiplication rule of P intersection B. This is basically comes from the conditional probability only. So we all know that probability of B given A is equal to what? We know that it is that P of A intersection B divided by P of A. So from that we can easily generate that, we can easily get that P of A intersection B is equal to P of A into P of B given A. Correct? So this is, sometime we will see that this is a very important formula. We call this as multiplication rule, right? And this is directly coming from the definition of conditional probability. Now, if we have three number of events, then we can extend this formula also. Like I'll show you. Suppose I have P of A intersection B intersection C. Then what will happen? You take maybe this to be an one event and this is another event. Then if you just apply the above formula, you will have P of A intersection B into P of C given A intersection B. Correct? So we just have applied this formula to here, and we consider this is an one event and this is another. Now if you have this, now this portion you put the formula you already have, just we are substituting this value. So it is P of A into P of B given A into, we had already P of C given A intersection B. Now see, if we just extend this formula for two event to three event, and we got this is the formula P of A into P of B given A into P of C given A intersection B. Now you think of its generalized version. If you have four number of events, what will happen? P of A into P of B given A, into P of C given A intersection B, into P of D given A intersection B intersection C. Correct? So with this, first of all, this one we have already derived, that P of A intersection B intersection C equal to, for 3 event, we'll have this formula, P of A into P of B given A into P of C given A intersection B. And we have already discussed that if you just extend this pattern, right, we can generalize this formula for n number of events intersection, and it is this one. So if we have n number of events and if we take the intersection, so P of I equal to 1 to an a intersection, like a1 a2 an intersection, it is equal to P of a1 into P of a2 given a1 into P of a3 given a1 intersection a2. Like this you have to extend it, and finally the last term will be P of an given a1 intersection a2 intersection an minus 1. I hope this rule is understandable. It is very easy. These are all coming from the definition of conditional probability, and after that we slowly extend it and we applied the same thing, and we can generalize this rule. I hope it is easy. Okay, now we'll solve some example. Look at the example. Jaya is undecided as to whether to take a French course or a chemistry course. She estimates that her probability of receiving an A grade would be 1 by 2 in a French course. So first of all, Joya cannot able to decide whether she will take a French course or chemistry course. And she somehow estimate that her probability of receiving an A grade would be 1 by 2 in a French course. So, and 2 by 3 in a chemistry course. So she already got some idea, maybe from somewhere, that from the previous years, seniors, maybe she took the opinion of seniors, and she understood that uh, the probability of receiving an A grade would be 1 by 2 if she takes a French course, and it is 2 by 3 if she takes a chemistry course. Now, if Joya decides to base her decision on the flip of a fair coin, what is the probability that she gets an A in chemistry? What does it mean? That Jaya finally decides that, okay, which course she will be taking, she will just flip a coin, and if it is one side, she will consider it is a, she will take a French course, in other side she will take that, it will, if it appears the other side, she will take the chemistry course. So you know that a coin have two sides, so she decides in this way by flipping a coin. Now the question is, what is the probability that she gets an A in chemistry? So all of you just think the question, just make the video pause, think about the question, what are the things are given and what you have to find, right? You have to first think by yourself. Just make the video pause and try to think of it. Okay. Now let us solve the problem slowly. So let us denote the some event with some name. Let's see with the event that Jaya takes a chemistry, and A denote the event that she receives an A in whatever course she takes. So C is the event that she will take a chemistry course, and A denote the event that she receives an A grade irrespective of the course she has taken. Because our ultimate aim is to get the A grade, right? So irrespective of the event that what course she takes, A is the event that she will receive an A grade. So these are the two an event we have denoted, C and A. Now again you pause the video and you understand from this question what are the things are given. Correct? So the question says she estimate that her probability of receiving an A grade would be 1 by 2 if she takes a French course, and it is 2 by 3 if she takes a chemistry course. Right? So we have not denoted, but if you denote that the if is the event that she takes a French course. Suppose we don't need it, but okay anyway. So if is the event that she takes a French course. Then from the first statement, what it is given that she receives an A grade would be 1 by 2. It is the probability if she takes a French course. That means she have already taken a French course. Then what is the probability that she will receive a A grade? What does it mean? It is the probability of the event A given that she has taken a French course. So in this case, it is given as P of A given F. And it is probability 1 by 2. It is given already. From the second line, the probability of receiving an A grade is 2 by 3 if she takes a French chemistry course. That means she will, what is the probability that she will get a grade given that she has taken a chemistry course? It means probability of A given C, and it is 2 by 3. I hope you understand. Now, if Joya decides to base her decision on the flip of a fair coin. Now, you let us again find one more thing. Can you tell me that what is the probability of that Joya will choose the chemistry course? So how she decides? She will flip a coin. If it is one side, she will take it is chemistry. In the other side, she will decide it is a French course. So what is the probability that she will take a chemistry course? Yes, it should be 1 by 2. And now what you have to understand that what you have to find out. What is the probability that she gets an A in chemistry? So this is uh, she gets an A in chemistry. That means she received an grade A and in chemistry. That means both the events are happening. That she received an grade A in the subject chemistry. So basically you have to find the probability of A intersection C. Correct? So this much it is given and you have to find P of A intersection C. Now how to find? We have already discussed the multiplication rule. So this formula is P of C into P of A given C. Now what is P of C? It is 1 by 2 into A of C is P of 2 by 3. So it is finally probability is 1 by 3. So this is the probability that she will get an A grade in the subject chemistry. I hope it is clear. Let me move to the next question. Yeah, this question already discussed, and then you can just have a snap of the full solution. We already discussed, but still if you think, you may keep a snap of it. Okay. Now I'll discuss another problem. 4 individuals have responded to a request by blood bank for blood donation. Right? So blood donation camp is going on maybe, and then 4 individuals have responded that okay, they want to give a blood to the blood bank. Now none of them has donated before, so their blood types are unknown. Yes, so their blood bank don't know their blood group. Next is suppose only type O positive is desired. So the blood bank only need the O positive blood. And only one of the 4 actually has this type. So these 4 individuals came to donate the blood. Among them, only one person have O positive blood. Others have the different one. Now again, if the potential donors are selected in a random order for typing, so they will be selecting just for randomly and on the order of typing. Then the question is, what is the probability that at least 3 individuals must be typed to obtain the desired type? So what is the probability that at least 3? That means, so one donor will come and that donor should not have the O positive blood. Then the next one donor also will come. They will type the second donor and the second donor should not have the O positive blood. Then after that, in third step or in fourth step, you may get the desired person who is having the O positive blood, right? But first and second selection, you should not have it. That's what it means. That what is the probability that at least three individuals must be type to obtain the desired type, right? So the first part is, now let us denote. Let A be the event that first type is not O plus, and B be the event that the second type is not O plus. That means O positive blood, right? So that means the whenever that she will type the first person, that person should not have the O positive blood. B is the event that first event already happened, then the second person came. Second person also should not have the O positive blood. Then it is remaining third and fourth, and then the desired person may get in third step or in fourth step. So the question, it says that what is the probability that at least three individual must be typed to obtain the desired type. That means the event A and B both should happen. Then only you will go for the third one. Na? At least third means A and B should happen. After that, we don't know. We may get it in the third step or in the fourth step. So A and B both should happen. So in this case, we have to find the probability of A intersection B. Okay, now we know some formula for it. It is equal to, by multiplication root, it is the probability of A into probability of B given A. Correct? Now think that what is the probability of the event A. So it is the case that the first type should not be O positive. Now we have four number of individuals. Among them, only one person have O positive blood. So our event A is first type should not be O positive. That means it should be among the other 3%. So what is the probability of the event A? Yes, it should be 3 by 4. Because 3 individuals do not have O positive blood. Only one have. So it is 3 divided by total number of person, it is 4. Okay, next. Probability of B given A. So the A event already happened. Then you have to find the what is the probability of the event B given that A has already happened. And A means that first person is not O positive. What is this probability? So once you have first person is already checked, so 3% are remaining. And among these 3%, 2% do not have the O positive blood. Therefore, what is the probability of P of B by A? Yes, it should be 2 by 3 because 2% do not have O positive blood and there are 3% remaining, so it is 2 by 3. And therefore, this probability of A intersection B, it is 1 by 2 if you just simplify. I hope it is clear. So this A and B will happen. Therefore, you should have at least 3 individuals must be typed to obtain the desired probability. Okay, now this exercise has another part. What is the probability that the third type is again O positive? We'll discuss about this. So that means the third type is O positive you have to get. So first, it in this case, suppose C is the event that the third type is O positive. Suppose C is this event. So to get this event, you basically have to have the first event should happen, second event should happen, then only you can go to the third one. And therefore, probability of the desired thing, it is the probability of the event C is actually C, A, B, and C, all three should happen, right? So in this case, the previous one was A, this one is B. In this case, you have to find the probability of A intersection B intersection C, right? Now we know the multiplication rule. It is P of A into P of B given A. into P of C given A intersection B. Now P of A value we have already checked. It is 3 by 4. B by A is 2 by 3. Now think about P of C given A intersection B. Now it is the case that the third type is O plus given that A and B both have already happened. And what were both A and B? First type is not O plus, second type was also not O plus. These two already happened. And C is the third type is O plus. So basically we have the two choice already left and they are not the O plus, O positive blood. Right? So how many percents are remaining? 2% are remaining. Among this, how many percent is having O positive blood? It is 1. Right? So probability of C given A intersection B is what then? So 2% are there. Among them, 1 is having this O positive blood. So it is 1 by 2. Probability of C given A intersection B. And if you simplify it, we'll be getting this value is 1 by 4. I hope it is clear. So all the things, whatever we have discussed, it is already written in a very explicit way. Right? You can just take a snap of it. And then the second part also, you can take the solution from here. So all these things are written in detail. Right? Let me move to the next question. A box of fuses contains 20 fuses, of which 5 are defective. If 3 of the fuses are selected at random and removed from the box in succession without replacement, what is the probability that all 3 fuses are defective? So a box you have where 20 fuses you have and among them 5 are defective. Now you will be selecting 3 fuses. How? So in successively you will take and without any replacement. So first you will take one fuse and you will keep it there. You will take another fuse, you will keep it somewhere, and you will take another fuse, you will keep it somewhere. Now here you have to find the what is the probability that all 3 fuses are defective, right? So again, let us denote the each of the event by some name. Let A be the event that the first fuse is defective. Let B be the event that the second fuse is again defective, and C be the event that the third fuse is defective, right? What you have to find that all 3 events should happen. So basically you have to find P of A intersection B intersection C. Now you know the multiplication rule formula. Apply that. It is P of A into P of B given A into P of C given A intersection B. This is a very easy problem. Now what is P of A? P of A is you have 20 fuses in the box. You will be selecting one among them and it should be defective. Where in the box there are only 5 defective pieces are there. So what is the probability that in the first attempt you will get a defective piece? Yes, it is 5 by 20. Next, P of B given A. So B is in the second attempt, you should not get the you should get the defective piece provided A has already happened. So in the first case already happened, you got a defective piece and you kept it aside. So what is the probability of B given A? So how many you because you have not replaced it, you have not kept it in the first fuse. So how many fuses are there in the box? It is 90. And how many one defective piece I have already kept it outside. So how many defective fuse is remaining? It is 4. So the probability of B given A it is 4 by 90. And similarly, in the third attempt, because first 2 fuse are the defective case, that is A intersection B, this has already happened. So third fuse is again defective. What is this probability? It is 3 by 80. Right? And if you just simplify it, you'll be getting this value is 1 by 114. This is a easy problem. Now I will discuss. So this is the solution of it. You may just have a look. You may take the snap of it, because all the things are, whatever we discuss, it is written explicitly. It will help you to make a proper notes. Now we'll discuss a very interesting problem. An ordinary deck of 52 playing cards is randomly divided into 4 piles of 13 cards each. Then you compute that the probability that each pile has exactly one ace. Right? So basically you have a standard deck of 52 cards. You divide it into among 4 person maybe. So you have 4 piles and each of them contain 13 cards. Right? Each of the piles will contain 13 number of cards. Now you have to find the probability that each pile has exactly one ace. So we know the card set of card is what? So you have 4 number of aces there, right? So of different type, maybe one maybe is of spade, one maybe of diamond, one maybe of heart, another maybe of club. You have to find that these 4 piles are there and each pile will have one ace. You have to find the probability of this event. Let us solve the problem. Let us denote some event E1, E2, E3 and E4 such that E1 is the event that the ace of spade is in one of the piles. You have 4 piles, each contain 13 cards. I am considering E1 is the event that the ace of spade is in one of the piles. Next, E2 is the event that ace of spade is in one pile and the ace of heart is in different pile. So where ace of spade is there, ace of heart should be in different pile. That is the event E2. Right? So E1 says that ace of spade is in one pile and E2 says that basically E1 already happened. So ace of spade is in one pile and ace of heart should be in different pile. Where ace of spade is there, you should not have ace of heart in the same pile. That is the event E2. What is the event E3? E3 is the event that the ace of spade, ace of heart and the ace of diamond all are in different pile. Now you have already have that ace of spade in one pile. If I am saying that E3 probability of the event E3, given that E1 and E2 happen, it means that ace of spade is in one pile, ace of heart should be in another pile, where ace of spade is there, it should be from different from that, and ace of diamond is also in another pile, because 2 other piles are remaining. So ace of diamond should be from other 2 piles. It should not be from the pile where ace of spade is there and from the another one where ace of heart is there. So E3 is this event. And finally, E4 is the event that all 4 aces are in different piles. Now, let us think the probability of each of this event. And what basically you have to find? Compute the probability that each pile has exactly one ace. So basically you have to find the probability of the event E4. But to get the E4, you should have E1, E2, E3, E4 all should happen. So basically E4 is equal to E4 intersection E3 intersection E2 intersection E1. So you have to find the probability of E1 intersection E2 intersection E3 intersection E4. So all 4 should happen. And we know the formula for that. So we have to find this one as we discussed, and we all know this rule, multiplication rule. So we'll have it is equal to P of E1 into P of E2 given E1, E3 given E1 intersection E2, and E4 given E1 intersection E2 intersection E3. Now we'll slowly find each of this probability. We'll slowly find each of this probability. Now, what is the event E1 and what is the probability of this event? E1 is the event that the ace of spade is in one pile. What is the probability? See, you have already distributed all 52 cards. So ace of spade should be in one of the pile, na? So what is the probability of the event E1? Yes, the probability that E1 should happen definitely. So probability of E1 is 1 because ace of spade should be is one of the pile now because you have already distributed all 52 cards. So A should be in one of the pile. So P of E1 is 1. Now next step that we already discussed, P of E1 is 1. Now we have to find the probability of E2 by E1. E2 given E1. What does it mean? So it means that the event given that the ace of spade is in one of the pile and the ace of heart is in different pile. Right? So this is E2 given E1. Now to calculate this quantity's probability, we will rather think that what is the probability of E2 given E2 complement given E1. And what does it mean? It means that given that the ace of spade is in one of the pile and the ace of heart is in the same pile, then only it is the complement because the E2 is the event that where ace of spade is there, ace of heart should be in different pile. We are talking about E2 complement, talking about the E2 complement. So that should be where ace of spade is there, ace of heart should be in the same pile. That is the E2 complement, given that E1 already happened. Now, what is this probability? See, we want to find that P of E2 complement given E1. Now, E1 is the event that ace of spade is in one pile. So, in that pile, how many cards are remaining? Because each of the pile have 30 number of cards. Huh? So, in that pile, one is ace of spade. So, how many cards are there? 12 number of cards are there. And in the standard deck of 52 cards, one is already given to the pile where ace of spade is there. So 51 number of cards are remaining. So probability of E2 complement given E1 is what? It is 12 by 51 because we have 12 remaining choices. So among them one should be ace of heart. So 12C1 divided by, we have 51 card is remaining in the standard deck. It is 51C1. So it is 12 by 51. And therefore we can easily get P of E2 given E1 is P of E2 given, this one we discuss, and then P of E2 given E1 is 1 minus this 12 by 51, and which is 39 by 51. Now we'll discuss about the second quantity. It is E3 given E1 intersection E2. Now what is this event? Given that the ace of spade and the ace of heart are in different pile, then the ace of diamond is in the third pile different from these two piles. Right? So again, we will try to find the probability of E3 complement given E1 intersection E. Now similar kind of argument we will apply here. So it given that E1 intersection E2 already happened, that means ace of spade is in one point, ace of heart is in different pile. And E3 complement is the ace of diamond should be one of these two piles. So how many ways it can be done? So the pile which contain ace of spade and the pile which contain ace of heart, how many number of elements they have total 26 number of 13 plus 13 26, but two are already there, ace of spade and ace of heart in these two piles. So how many choices remaining? It is 24. And in the standard deck, how many choices are remaining? So two have already taken, so 50 choices is remaining, and therefore we can easily write down that P of E3 complement given E2 that we discussed, it is 24 by 50, and then P of E3 given E1 intersection E2 is 1 minus this quantity. So this is 26 by 50. Then next, with the similar kind of argument, we can say that what is the P of E4 intersection given E1 intersection E2 intersection E3. How we can calculate? So first we can calculate that P of E4 complement given E1 intersection E2 intersection E3. So it is the event that the S of club should be in one of the three pile where these three different piles are there. So there are how many choice? All total they have 39 number of card, but three aces are already there. So you have only 30 choices, 36 choices are remaining. And in the standard deck, you have taken three cards, so there are 49 cards are remaining. So you have 36 by 49 of this probability, and therefore P of E4 given E1 intersection E2 intersection E3 is 1 minus this quantity, therefore it is 13 by 14. And then all together, if we substitute all this value in the formula of the multiplication rule, we'll get this is the answer. Therefore, there is approximately 10.5% chance that each pile will contain the S. Right? So you can just have a look up the whole solution. You can take a snap of it. This is the previous slide. This is a very important problem and a very interesting one. And all the content I have taken mostly from these books. Right? If you like the video, please just give your feedback. I hope these videos are helpful. In the next lecture, we will be discussing about the independent event. Thank you very much. We'll meet in the next lecture.